This last segment covers what are known as the product to sum identities and the sum to product identities. There's a whole bunch of them. I could never memorize them, although my pre-calculus teacher made me in 11th grade at one point, but I promptly forgot them. I would expect you to have them on your cheat sheet. All right, so this is just one example of a product to sum identity. We have a product, sine x times cosine x, being expressed in terms of a sum, sine of x plus y, plus sine of x minus y. And then we have what are known as the sum to product identities, going the other way. These two sets are very intimately related. Sine of x plus sine of y, a sum, being equivalent to a product. 2 times the sine of the average of these things times the cosine of x minus y over 2. All right, and we can apply these in example 7. We're asked to prove that this crazy thing is equal to the tangent of 2t. And the first thing that we're going to do is re-envision the numerator using the sum to product identities. Okay, so we have the sine of something plus the sine of something else. And according to this, that could be 2 times the sine of the average times the cosine of the difference over 2. So how's that going to look? Let me stop this and rewrite that. Alright, so I've used this first sum to product identity to rewrite the numerator here. Okay, so that's what that is. X and y are t and 3t. And then simplifying these arguments, t plus 3t over 2, 2t, this becomes negative t. Alright, so that is the numerator here. The denominator, we can use a different of the sum to product identities, which are not written here, but is in your textbook. And it looks like that, and we end up with this. Okay, so now let's put it all back together and see where that takes. So all I've done here is I've taken these pieces that we've made from the numerator and denominator, and I've put them back in the numerator and denominator. Okay, and we're trying to prove that that's equal to tan 2t. Well, some stuff cancels, right? The 2's and those cosines of negative t, and we're left with sine 2t over cosine 2t equals tan 2t. Well, this is defined to be the tangent of 2t. So we're done. Alright, so that's how we have an example of using the product to sum and sum to product identities. Alright. What I would like you guys to do, you accelerated lot that have opted for this hard road, on page 600, 1 through 69, every other odd. Alright, so that'll be in addition to the section 10.1 and section 10.2 homework that everybody has for this week. Alright, good luck, and write to me with problems that you would like me to discuss further.